All right, so for this problem, let me fix the mic. Okay, for this problem, we're doing binary search. This is, I think, a good problem for everybody who wants to start, tackling these LeetCode problems. At least understand binary search. It's a pretty good algorithm to understand, to learn. One of the first ones that I learned when I was reading this textbook that I got. So let's read the problem. So it says, given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return this index, otherwise return -1. You must write an algorithm with O log of n runtime complexity. So yeah, so binary search, if you guys don't know, it runs in a log of n. The time complexity is log of n. But basically, like when you first see this problem, if you don't know what binary search is, you can basically implement an n squared solution by using two for loops. One to loop through the array, and the second one to check if the target is in the array. And then you do like an if statement if it is in the array. After looping through the array, then return it, and if it's not, then return -1. But we want to do log of n runtime complexity. So binary search, the way I learned it was basically assume that pretend that we're giving numbers between 1 and 100, right? And we want to guess a number that, say, the person who's doing this game knows. But say the number is 80, right? We can guess each number, right? 1 up till 100 until we get to that problem. Until we get to that target. But that's like the n squared solution, because we're gonna loop through the whole array and start from 1 all the way up to 80 in this case. So it'd be 1, nope, that's not it. 2, that's not it. 3, that's not it. 4, that's not it. 5, that's not it. The thing that I didn't mention in this game, let's say, so to speak, every time we guess, we will be told whether the number is less than our target, greater than our target, or if we found the target. So, for example, we guess 1, they'll say, no, your number is less than the target, right? 2, no, your number is less than the target. And we're going to keep going until we reach 80, and they'll say, yep, 80 is the target. But a good way to approach this is to start off with half, right? Start off with half of the numbers. If they're telling you whether your number is less than, greater than, or equal to the target. So we'll start at 50. The person will tell us 50 is less than your target. So we know automatically, because 50 is less than our target, we know that anything to the left of 50 is obviously still going to be less than our target. So we update our new bounds. We say, okay, from 51, not from 50, but from 51, because 50 was less than our target. So anything up to 50, including 50, would be eliminated. So from 51 now to 100, we guess. Let's guess half of that again. Say 75, right? They say, nope, 75 is still less than your target. Okay. Now we know that anything up to 75, including 75, is less than our target. So now we go from 76 to 100. Do half of that, right? Half of that is, so 76, the difference between 100 and 76 is 24. Half of that is 12. So we're going to say 87, or 88. We guess 88. They say, no, your number is greater than the target now. Okay, so now we know that our number has to be between 76 and 87, because 88 and anything above that is greater than our target. So we do 76 and 87. The difference between those two numbers is 11. Half of that is 5.5. Remember, we're going to be working with integer division, so we just do 5. So we're at 76 plus 5. That gives us 81. We guess 81. No, your number is greater than the target. We keep going. Now we know that numbers between 76 and 80. Half of that would give us 78. 78. No, your number is less than the target. And we keep going. Say 79. Nope. And 80. Boom. We got it. If you go back in the video and see how many times that was, at max that was 7 times. That's because binary search allows us to pretty much keep cutting our numbers in the array by half every time. That gives us the log of n solution, right? And we're gonna do the same thing here. Let me get this array here. I hope that explanation made sense, and if it did not, I'm sorry. There are other videos that explain it. I wish I could explain it with like my iPad, but I cannot get that into Streamlabs right now. So our output should be 4 here. Oh, that's gross. was doing it backwards. Okay. So let me put the indexes here. This is 0 index, 1 index, 2 index, 3 index, 4 index, and 5 index, right? And basically what I was doing is I was trying to find the range, right? So I was using 2 pointers. This is also known as like the sliding window approach. I have a left pointer here, and I have a right pointer here, right? We have our left and right pointers are balanced, like in the problem that I gave you. We had from 1 to 100, okay? These are our pointers. Now, we need is the midpoint. We knew that in that 1 to 100, half of it is 50. So we have to find half of this array. So we have 1, 2, 3, 4, 5, 6. Half of it will be, we have 6 values. So half of it will be the third value, right? So it'd be here. So now, what we do is we check, okay, is 3, we're going to guess 3. We're always going to guess the midpoint. 3. 3 is less than our target. So what do? We know that anything up to the value 3, where our midpoint's at, including 3, including this value, will be eliminated. We don't have to worry about that. So we update our left pointer. So our left pointer now sits here. And we have to update the midpoint as well. So now our midpoint will be half of this. That makes sense? So this would be 1, before, it'd be here. Now we guess this. Okay, is 9 equal to our target? It is. So now we would just return the index where our midpoint is pointing at, which would be the 4th index, and that's the correct output, right? So let's write this in code. First, we want to have a left pointer, right? And then our right pointer is going to be the end of the array, right? So we can do nums.size. But remember, nums.size gives us the actual size of the array. Here, the size of the array is 6. We're working with, because there's 6 elements in this array, right? But we're working with index based, and index based starts at 0, right? We need to subtract 1. Now we need to do our loop. So when will our loop, like when we have to think about our conditions. We're gonna do a while loop, and while our left pointer is always less than or equal to our right pointer, and we're gonna be looking for that target. Okay, and I'll explain a little bit on this with the other examples, the other test cases. So once we have our conditions, we need to get our midpoint. We know our midpoint is equal to, well, it's equal to right minus left divided by 2. But this will give us some integer overflow, which you'll experience with extreme test cases. So we want to basically just add left plus in front of it. And this is the same thing. For example, if we put the left pointer here, and we're going to try to find the midpoint here, using the first equation, using just what I highlight right here, right minus left gives us 5 minus 0. Divided by 2, it's 2.5. Integer division, so we truncate off the decimal. So that gives us this midpoint. Using the other equation, it's the same thing. Right minus left divided by 2, that gives us 5 minus 0 divided by 2, 2.5. Plus 0 is still 2.5. So that still works, okay? Okay, so now we just do our if statements. So let's do if nums of mid, right? If our index value in the array nums of our midpoint is equal to our target, well, we know just to return that value. Okay. However, else if nums of mid, if the midpoint that we're at is less than our target, we know that everything to the left of it is also going to be less than, right? We proved that in the example. So we need to update our left pointer. Our left pointer now gets updated to mid. But remember, mid was the point that we saw that was less than. So we don't need to include that. So we're going to add +1 to it. And then our last else statement, which is basically, this is saying if nums of mid is greater than target. So our last else statement means that we update the right pointer, because that means our guess is greater than the target. So we know that everything to the right of it, including that point that we guessed, is going to be greater than our target. So we update our right pointer and bring it to like narrow down our range. So we're going to update this to be mid -1. And while we're in this loop. We're going to keep finding. If we don't find nothing at the very end, we return -1 if our loop breaks. Okay. And I'll show how the loop breaks with, let's say this. Yeah, this example is perfect. Okay. And here our target was 2. And our output here should be -1 because it doesn't exist, right? So adding the pointers, we're initially going to start off with left and right? And let's find the mid using our formula. Right minus left gives us, let me put the indexes here for you guys. Okay, so right minus left is this 5 minus 0, that's 5. Divided by 2 is 2.5. Plus our left, which is 0, still 2.5. Remember, integer division, truncate off the decimal. So we're left with 2. So here's our midpoint. Okay, 3. Is 3 greater than, less than, or equal to our target? Our target is 2, so it's greater than. So what we do is we basically eliminate everything, including our midpoint, and to the right of it. So all this would be gone. So we update our right pointer to be what? Mid -1. So here's mid -1. Here's our right pointer. Now we find a new mid here using the formula, right? We have mid is equal to right minus left. So that's 1 minus 0. It's 1. Divided by 2 is 0.5. Plus 0 plus our left is still 0.5. But we truncate off the decimal. So our midpoint is now at index 0. These are our new pointers. Now we're at -1. Is -1 less than, greater than, or equal to our target? It's less than. Okay, so that means everything to the left of it, including index 0, will be eliminated. So we update our left pointer using our formula here. So left is equal to mid plus 1. So mid is 0 plus 1. Left is here. Now we got to get a new mid. Our new mid here says right minus left. So that's 1 minus 1, 0. Divided by 2 is 0. Plus 1 is 1. So our new mid will be here. All our pointers are pointing at index 1. Is 0 less than our target, greater than, or equal to? Well, it's less than. So we use this formula. Left is equal to mid plus 1. Left is here. Now, notice our loop broke because left is now greater than right. So we break off and we came to the conclusion that we will return -1 after this loop because our target is not in our array. Our target should have been here. Should have been there. Because, right, we're given that the array of integers nums is sorted. That's why we can make this conclusion. Important to know, I should have mentioned this in the beginning. To do binary search, you must have a sorted array. Sorted in increasing order. Okay, so that's it. And this should work. Okay, and I already did this problem a couple of times. So yeah, that's it. And I hope you guys enjoyed. Be sure to comment, like, subscribe, and I'll keep doing these videos. I'm learning as I go. Currently a student, and I feel like this is a good way for me to keep moving forward with my skills. So I hope you guys can do the same. All right, bye guys.